Alright class, today we are going to use a ballpoint pen spring, 2 paper clips, 2 D-size batteries, a ruler, and a stopwatch to determine the spring constant of a simple ballpoint pen spring. The spring is 19 millimeters long, each battery is 139 grams, and each paper clip is 1 gram. We're going to attach the paper clip to the battery like so, and then hang them from the spring. They'll spin for a little bit, and they'll eventually come to rest at the spring's stretched length. The length of the spring when it's stretched with one battery is 27 millimeters, and then what I did next is I attached a second battery to the first battery. It weighs 279 grams because 139 battery plus 139 battery plus 1 paperclip equals 279. I hung the 2 batteries in the paperclip from the spring and let them spin around until they stopped so we could measure the stretch length of the spring. The new stretch length of the spring is 37 millimeters, and then I took the spring length and put it on the x-axis and then paired it up on the y-axis to the force that was on the spring, which I calculated by multiplying G 9.8 times the mass of whatever was hanging off the spring, and got this graph. The graph is fairly linear, so I calculated the line of best fit. The A value is the K value of the spring because it is force over distance, F over X. Then I graphed the line of best fit here. The line of best fit goes almost exactly through the points, so I used the experimental K value of 151.257 and calculated the theoretical period of the spring and got 0.27 seconds. Then I attempted to time the actual period of the string. I timed it over multiple periods and divided, and got about 0.265 seconds for the experimental period. Here's my list of possible reasons for errors in the experiment, and also my conclusion, which lists that I calculated for the spring constant correctly, using the correct values, because after I calculated the theoretical period, I timed the actual period, and the two were very close, even though they're not exact.